Welcome to section 5.5, and as promised before, um, we are dealing with substitution, and so here we go. Example number 1. We are taking the integral from or of 9 3x minus 6 raised to the negative fifth power dx, and we are told specifically to use u be 3x minus 6. Now realize with a little bit of practice this is going to become very uh, secondhand, but basically we take, this is the most complex part of the problem, and we take the innermost part of it, and that's usually what u is going to be. The very first thing we do is we find the derivative of u, which is 3 with respect to x. Then we immediately solve for dx, which is 1/3 du, or du over 3. But then what we do immediately is we substitute in for things that we know. For example, we don't have anything for that 9, so the 9 is going to remain there. But 3x minus 6 becomes u to the negative fifth power, and the dx becomes 1/3 du. Now cleaning this up, 9 times 1/3 is 3, u to the negative 5 du. And so finally we can take the integral, which would be 3 u to the negative 4 over negative 4 plus c. And then, since this is not a definite integral, what we have to do is we have to resubstitute back in for the u. And so our final answer will be 3 times the quantity 3x minus 6 raised to the negative fourth power over negative 4 plus c. Example 2. We have the square root of x cosine squared of x to the 3/2 minus 2 dx. And the most complex part is right here, the cosine squared. So we take the innermost stuff and we get u equals x to the 3/2 minus 2. And that was given. Du would equal 3/2 x to the 1/2 dx. And so dx would equal 2/3, or actually 2 over 3 root x du. So now we just substitute back in. So we don't have anything for the square root of x. It's going to be cosine squared of u, and then dx is going to be 2 over 3 root x du. And notice the root x and the root x cancel each other out, so we're left with cosine squared of u, 2/3 cosine squared of u du. Now, when we take the integral here, we have to realize this is, what we actually have to do is we have to take the another substitution. Realize if we do this step right here, then all the x's should be gone. Now that we're going to have to do another substitution, we're going to call it v, we better make sure that all the u's disappear. So v, I'm going to let, this is the most complex part, so I'm going to let v be cosine of u, because this is the most complex phrase, but we only take the innermost part, which is the cosine of u. So dv would equal negative sine, oh, hold on, this isn't working out very nice at all. let's see, what do we need to do here? Oh, we just need to use the work backwards. There, okay. We just have to realize that it's going to be 2/3. Increase this to, this will become a cosine cubed of u, but we have to divide by the reciprocal, or not the reciprocal, but the derivative of this inside, so that would be negative sine of u. And so then this will equal 2/3 times cosine cubed of u, but u is x to the 3/2 minus 2 all over, let's put the negative out there, the sine of x to the 3/2 minus 2 plus c. And there is the final answer for number 2. Number 3 says evaluate the integral. So we have to determine what we're going to use. We've got x squared and the square root of x cubed plus 3 dx. Now look, this is the most complex part, so taking the innermost part, that's what I'm going to let u equal. U equals x cubed plus 3. Then I'm going to take the derivative of both sides, which will be 3x squared dx, and immediately solve for dx. Dx is equal to 1 over 3x squared du. So what am I going to get? Well, I get an x squared, because I haven't changed anything there, the square root of u, and instead of dx, I'm going to put in 1 over 3x squared du. The x squared and the x squared cancel. So once again, if I've done it right, all the x's will disappear at this step, as they did. So we're doing good. And so this becomes, cleaning it up, the integral of 1/3 u to the 1/2 du, which means I can now integrate this. It's going to become 1/3, and then the this becomes u to the 3/2, and it'll be times 2/3 because we divide by the new exponent. And so plus c, and so cleaning this last step up, we get 2u to the 3/2 over 9 plus c, and then resubstituting back in for u, we get 2 the square root of x cubed plus 3, that whole thing raised to the 3rd power, all over 9 plus c. Example 4. The integral of cosecant squared of 4 theta plus 2 d theta. Okay, this is the complex part. Take the innermost part. So I'm going to let u equal 4 theta plus 2. The derivative of u would be 4 with respect to theta. So d theta would equal 1/4 du. So let's see what happens here. We'll get cosecant squared of u, and instead of d theta, it's going to be 1/4 of du. And basically, once again, theta should be gone. Well, it happened to fall out pretty, um, I mean, pretty simply in that situation. But then cleaning this up, we get 1/4 of cosecant squared u du, which is equal to 1/4 when we actually take the antiderivative. That is negative cotangent of u plus c, and then all we have to do is resubstitute back in for u. Negative 1/4 cotangent of 4 theta plus 2 plus c. 5 and 6 say multiple substitutions, which means we start out with u, then we have to go to a v because we still need to do something else, and then we just need to put back what we began with. So, number 5, we get x cosine of 27x squared times the square root of sine of 27x squared all over 4 dx. Now we look at what is the most complex part, and the most complex part here is this part right here, just that part right there. Take what's on the inside, and that's the sine of 27x squared. So we get u equals the sine of 27x squared. We immediately do this thing. Du equals the sine of 27x squared. Well, the problem is we need to do another substitution. V would equal 27x squared. Okay, so that this would become, so then we immediately do this. dv would be 54x dx. So dx would be 1 over 54x dv. So what we're going to do is this now becomes the sine of v dv, but dv is 54x dx. So now we immediately solve for dx here. Dx would become what? Sine of v 54x over 1 du. So now we've got all this mess here. We now substitute in what we know. We have no substitution for x. We have no substitution for cosine of 27x squared. We do have a substitution here. This would be the square root of u over 4, and then dx is 1. Whoops, I messed up here, way up here, because the derivative of sine of v becomes cosine. That's where I'm messing up, and it was really bugging me why it wasn't going. This should be cosine. And so this one should be cosine also, which helps a whole lot because it will get rid of what I need to get rid of. So it's the cosine of v 54x. And of course we have to realize that v is equal to 27x squared. So what happens is this x here cancels with this x here. This cosine of 27x squared here cancels with this cosine of 27x squared here. And remember that at this stage, all my x's need to go, and they are finally all gone, and it boils down to this relatively simple problem. Square root of u is there, and in the bottom 54 times 4 would be 216 du. So just rewriting this in user-friendly form, we get 1 over 216 u to the 1/2 du. And so this will equal 1/216 u to the 3/2, 2/3 like that, plus c. And let's see. This becomes square root of u cubed. Okay, 108 times 3 is 324 plus c. And then the final resubstitution in, we know that u is equal to the sine of 27x squared. So this becomes the square root of sine cubed of 27x squared all over 324 plus c. And realize that up here in this, when you do that second substitution, as soon as you need that second substitution, you take care of it immediately to deal with this problem here. So final answer, the square root of sine cubed 27x squared all over 324 plus c. Number 6. The integral of 5, 3x squared minus 4 times sine to the 5th of x cubed minus 4x cosine of x cubed minus 4x dx. Okay. Now here we could certainly argue which is the more complex, but I'm going to argue that it's this one right here, because it's the 5th power. So we take the innermost part, which is x cubed minus 4x. So we're going to let u equal x cubed minus 4x. Let's immediately take care of this. Du equals 3x squared minus 4 dx. And so dx would equal 1 over 3x squared minus 4 times du. So let's see what that gives us. The 5 is going to remain. The 3x squared minus 4. Realize it's nice to see that because it is going to eventually disappear. Eventually. Then we get sine to the 5th of u, cosine of u, and then dx, we're going to put in 1 over 3x squared minus 4 du. So let's clean this up. 3x squared minus 4, 3x squared minus 4. Okay, those are gone. All my x's are gone. So now I'm left with 5 sine to the 5th of u cosine u du. Now we look at it. What's the most complex part? Most complex part is sine to the 5th of u. The innermost function there is sine of u. So I'm going to let v equal sine of u. dv would equal the cosine of u du. and then immediately solving for du, du would equal 1 over cosine of u dv. So let's see what we get there. Now if we do this properly, all of our u's should disappear. So it's going to be 5 v to the 5th. We don't have any substitution for cosine of u, but du is equal to 1 over the cosine of u dv. So just substitute that in. So cosine of u cancels with the cosine of u, which leaves 5 v to the 5th dv. Now we can finally integrate this. This becomes 5 v to the 6th over 6 plus c. Now we resubstitute in for v. v is sine, so it's going to be sine to the 6th of v over 6 plus c. And then we have to resubstitute in for, whoops, that should be sine of u, not v. And then we plug in for u, and u was x cubed minus 4x. So this becomes 5 sine to the 6th power of x cubed minus 4x all over 6 plus c. And there is the final answer for number 6. 7 and 8 are initial value problems, which means we need to find or solve for c and then go from there. So let's see what we've got. Number 7, we are told the derivative is 18 times that. So I'm going to immediately put it into the integral. I'm going to take the integral of 18, then what? 6x minus 5 raised to the negative 6 power. And we'll deal with y of 0 equals 1 a little bit later. But right now, I realize this is the most complex part, and the innermost part of that is 6x minus 5. So u is going to equal 6x minus 5. Take the derivative of u, and get 6 dx, and solve for dx. That gives me 1/6 du. So substituting in, there's nothing to do with the 18. The 6x minus 5 is actually u now. So it's u to the negative 6, and whoops, this has to be a dx, because now dx is going to be changed in for 1/6 du. So this becomes 3u to the negative 6 du. It's not difficult to integrate now. This becomes 3u to the negative 5 over negative 5 plus c. And so this will equal 3, and u is 6x minus 5 raised to the negative 5th power over negative 5 plus c. Now we are told y of 0 equals 1. So I just need to plug in 0 in for x. And so what I get is 3 times negative 5 raised to the negative 5 power over negative 5 plus c. And I've done something I shouldn't have. I shouldn't say it's equal, because now this whole thing needs to equal 1. Okay, boy, this is a nasty number here. Let's see. So I get 3 over negative 5 raised to the negative 5th power, brings it down here. I'm going to end up with a positive 5 to the 6th power, whatever that is. I can't. I don't have that exact number available. Um, and so let me grab a calculator real quick. Okay, I was finally able to find a calculator. And so this becomes 3 over 15,625 plus C equals 1. And so when we subtract 3 over 15,625 from both sides, C becomes 15,625 minus 3 would be 15,622 over 15,625. And so the final answer, since we need to plug it back into our last equation here, the original equation y equals 3 times the quantity 6x minus 5 raised to the negative fifth power over negative 5 plus 15,622 over 15,625. Number 8. Number 8, we're told the second derivative is equal to negative 72 cosine of 6t. So we have to keep that in mind because we're actually looking for the original, so we're eventually going to have to take two integrals. This is negative 72 cosine of 6t dt. So the first thing we need to do is find a u. Most complex is cosine of 6t, so we're going to let u equal 6t. du would equal 6 dt, and so dt would equal 1/6 of du. So this becomes negative 72 cosine of u, and dt is going to become 1/6 du. So this will simplify to a 12, so we get negative 12 cosine of u du. So we can integrate this. The integral of cosine of u is sine of u plus c. And we're told that the first derivative of 0 equals 12. So that means, we need to do resubstitute back in. So this becomes negative 12 sine of 6t plus c. So then negative 12 sine of 6 times 0 plus c equals 12. So let's see. Sine of 0 is 0. Negative 12 times 0 is 0. 0 plus c is 12, so that means c equals 12. So what our first derivative would equal would be negative 12 sine of 6t plus 12. Now that's the first derivative. So now we need to integrate again. Negative 12 sine of 6t plus 12 dt. We're going to use the same u and v that we had before, the u and du and all that stuff. So what that will become is negative 12 sine of u plus 12 times, let's see, 1/6 du. So the 1/6 will make this a negative 2 sine u plus 2 du. And we can finally integrate, so this becomes Let's see, the integral of sine, this actually would change to a positive. So that becomes positive 2 cosine of u plus 2u. And resubstituting back in what we had, since u is equal to 6t, it becomes 2 cosine of 6t, and I forgot the plus c. 2 cosine of 6t plus 2 times 6t, well 2 times 6t is 12t, plus c. So now, 2 cosine, since we know s of 0 equals 8, that means I should be able to plug in all this. So 6 times 0 plus 12 times 0 plus c equals 8. Let's see, cosine, 6 times 0 is 0. Cosine of 0 is 1. So this becomes 2 plus 12 times 0 is 0. C equals 8. So that means c would have to equal 6. And so rewriting back into this last one, our final answer would be 2 cosine of 6t plus 12t, and c is now equal to 6. So that's what y equals. And there is the final answer for that. And finally, example number 9. Example number 9, we're given the velocity and the initial position. We need to find the body's position. So we have to remember the derivative of position is velocity. So the integral of velocity would be position. So we need to take the integral of 8 over pi sine of 4t over pi dt. Well, the most complex part is this right here. I mean, after all, this is just a number, but we take the innermost part, and that's what u is going to equal. So u will equal 4t over pi. Take the derivative of both sides, so du will equal 4 over pi dt. So that means dt will equal pi over 4 du, and we divide both sides by 4 over pi. So rewriting this, we get the integral of 8 over pi times the sine of u, and dt is going to be pi over 4 du. Now let's see, the pi's go, this will simplify to a 2, so it becomes 2 sine of u du. So when we integrate this, we get 2. The integral of sine is a negative cosine of u plus c. So let's see, this becomes negative 2 cosine of 4t over pi plus c. Now we can finally say, since we know s of pi squared equals 2, that means we should be able to put in pi squared right here. So we get negative 2 cosine of 4 pi squared over pi plus c, and once again I did the equal sign not meaning to, and this will equal 2. So let's see how this all simplifies. That will cancel with that, so we're left with 4 pi. The cosine of 4 pi is 1, and so I get negative 2 times 1 is negative 2. Negative 2 plus c equals 2. Add 2 to both sides, so that c equals 4. Final answer would be negative, or s would equal negative 2 cosine 4t over pi plus 4. And there is what was asked.